I hope you went through writing all those electron configurations and seeing how to do that, how to follow that diagram with all of the arrows. So now moving forward, okay, I don't know if this is going to take one or two more, but moving forward, these are, if you remember, there were 3 in the video that I said let's put stars by them. So these are the ones, and remember these are the configurations. So hydrogen was 1s, lithium was 1s2, 2s, sodium is 1s2, 2s2, 2p6, 3s. And again, if you're still confused by this, you can go back through that video. All right. So what I did is I put them on the periodic table. This is a blank periodic table, and you'll notice where these are is that they're all in the first column. So that means this is 1, and this is row 1, row 2, row 3. I don't have them numbered yet, but I will in further slides. So this is row 1, and it's S1. Row 2, and it ends in 2S1. Remember, we don't write a 1 superscript. This is in row 3, and it ends in 3S1. So what would you expect for potassium, right? Okay, potassium is on the periodic table right there. And so you would expect 1, 2, 3, 4, S1. And if you write it out, there's 19 electrons. And so if you go 1s2, 2s2, 2p6, 6, 8, 10, 3s2, that's 12, 18, 20. So you see S1. These are all S1. So we have a pattern. What's interesting, and you'll see this in a later set of videos, the periodic table was put together not based on structure, but based on behavior, based on properties, and yet you get the same relationship. So that's what's really cool. Structure-function relationships are very important in chemistry. So you can think of the periodic table as being like a map. And so these are the columns, right? And if you look at this, if you look at the very first row, it's 1s1, 1s2, right? 1s2. Then it goes 2s, 2s. Then you go across here, 2p, 2p. Then it goes 2p, 3s, right? Then it goes 3s, 3p, 4s, right? 3s, 3p, 4s. Then it goes 3d, 4p, 5s, right? 4s, 3d, 3d, 4p, and then 5s following this. Then 4d, 5p, 6s, 4d, 5p, 6s. And it gets weird with the f's, but it goes 6s, 5d, 6s, 4f, 5d, 6p, 6s, 4f, 5d, 6p, and so on. So it's a map. The periodic table is a map. And so you can think of it like giving directions. So think of it like giving directions. So this is the S1 column, this is the S2, this is the P1 and the P6 column, this is the D1 through D10 columns. These are the energy levels, so row 1, row 2, row 3, row 4, 5, 6, and 7. So this is the 3S, this is the 3P, this is the 4S, the 3D, and the 4P. 5S, 4D, 5P. All right, so we're going to do a few more from the video that we did, and you'll see, and think of it like you're giving directions. Think of these as street names. So this is the 1S street, and this is the first house and the second house, and this is the 3P street here, and there's 6 houses. All right, so for example, we did sulfur. Right? So if you look at sulfur, in the video we did sulfur, and you can say, how do you get to sulfur? Well, you go down the 1S street, you go past the second house, then you go to the 2S street, go past both houses, 2S2, then you go to the 2P street, go past all 6 houses, 2P6, then turn down the 3S street, go past the second house, 3S2, then turn down the 3P street, and it's the 4th house, 3P1, 2, 3, 4. So if you want to think of it like that, it's pretty cool. All right, we also did, if I recall, we did iron. So you want to find it on the table and then just give the addressing system. So iron is going to be, and remember it was in the video, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 1, 2, 3, 4, 5, 6. Right? I'm keeping the valence in red just to remind you. Remember, the valence is the energy level, so everything in here with a 3. You find the highest number 1, 2, 3, and 4, so it's the 4. Okay, we also did arsenic. So arsenic, you want to find it on the table. So see how it appears on the periodic table here. Right? And then we do the same thing. So you go down the 1S street, go past both houses, 1S2, right? down to 2s, 2s2, 2p6, 3s2, 3p6. This goes to the column. 4s2, go down the 3D street, go past all 10 houses, turn down 4p, it's the third house. So 4s2, 3d10, 4p3. Right? And we did that before, but we did it by counting. So that's why a periodic table is very important to have. You should put one up on your wall. Okay, there is a blank one on the website if you want to print it. There's also a regular periodic table. All right. So let's try a couple more doing it this way. So try these on your own. You can hit pause here and give it a go. Okay, so try them on your own. I don't remember if I have it on the next slide. I do. All right, so try these on your own. Or hopefully you tried them on your own. I'm sorry. Let's go back. Try them on your own. Hit pause. Give it a go. And then come back. All right. Did you try them? So here's our map with the stuff we filled in. So the first thing you do is you find aluminum on the periodic table. Aluminum is right here. And so then you should go 1s2, 2s2, 2p6, 3s2, 3p. There you go. See, much easier than having to keep track of counting. And it's getting used to using the periodic table. Okay, so try strontium. Okay, hopefully you tried it on your own. You want to find it on the table, and it's right here. This is where strontium is. And so it's the same thing. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and there it is. See that? Okay, one more of these. So let's look at tin. Okay, again, you want to find on the table. Excuse my bad handwriting. So it's going to be similar, right? You're going to go for the same thing. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. And of course, remember the valence is everything with that highest number. So the 5s and the 5p are the valence. All right, see how to use it from there? Now, that's a lot of writing. If you think of it like giving directions, this is how you would give directions to someone from out of town. You say, okay, you're at your hotel, back out of the driveway. If you use your phone or your car to give you directions, right? That's what it does. It tells you like how to get out of your driveway and go to the end of the street. But if you're from town, you know your way around a little bit, you give directions from a common landmark. So for example, if you're saying, well, how do you get to Mesa College? Now from Mesa College, you take the 805, and from the 805 you do this, right? Or from the 163. You go to a common landmark. Well, we can do that as well. There's a shorthand notation. So the last column on the periodic table is called the noble gases. Helium, neon, argon, krypton, xenon, radon. And so what you can do is you can find the noble gas prior to the element you're doing and then go from there. So you'd say, well, from neon here, and what you do is you put the noble gas in brackets. And what it means is the configuration of, but it still allows us to get the valence. You can only put noble gases in brackets. You can't start from, say, calcium. You have to start from the noble gas, and there's always a noble gas before it. So if we do the ones that we already did here, aluminum, right? So aluminum is here, but what you could do, this part here, the 1s2, 2s2, 2p6 is the configuration of neon. See, 1s2, 2s2, 2p6. So you say, well, it's like neon plus this. So you'd say neon, 3s2, 3p. So how do you get to aluminum? Well, you go to neon, and from neon, you go 3s2, 3p. So for strontium, well, how do you get to strontium? Well, you go to krypton, but you can't go to krypton because it blew up. But you go to krypton, right? And then from krypton, it's 5s2. See, much cleaner, and yet you still get the valence. So for tin, how do you get to tin? Well, you go to krypton, then it's 5s2, 4d10, 5p2. All right. So, whoops, I don't know why I did that. There. All right. Try 3 more. Try these on your own. Vanadium. How did I do this? Okay, let's go back. Try these on your own. Try vanadium. Okay, hit pause and try it on your own. All right, and so for vanadium, you say it's argon, 4s2, 3d3. See that? How about germanium? All right, so find it on the table, do it on your own. Okay, so germanium is right here on the periodic table. So how do you get to germanium? Well, you go to argon, and then it's going to be 4s2, 3d10, 4p2. Right? And the last one, iodine. So we're going to find iodine on the table. Again, I'm going to count to 5. All right, did you try it? First you find it on the table. How do you get to iodine? Well, you go to krypton, then 5s2, 4d10, 5p5. All right? All right, so I'm going to stop this video here. Well, this is a summary of the entire periodic table, and it just has the outside. Now, what you want to be careful, some of them have weird ones. See how chromium, instead of being 4s2, 3d4, is 4s1, 3d5. For Chem 152, everything follows the pattern. So don't worry about the ones that do weird things. There's a reason for it, but we're not going to go there. But this will help you if you want to print this out to make your life easier. But you have to be able to do it on your own from a blank table without configurations on the test. But this can help you look things up. All right, I'm going to do configurations of ions on another video. So we're going to stop this video here, and we'll pick up on one more video.